Hello everyone. I welcome you all for today's session on machine learning with Python. Module 3 Artificial Neural Network, Lecture 4. I am your friend Madhaves, Assistant Professor, Department of ENC, Gausia College of Engineering, Ramnagaram. If you're not subscribed to my channel, subscribe to my channel, click on the bell icon for further notification or share with your friends for their benefits. First, as we have seen in the previous session about Perceptron, today we are going to cover in detail about the Perceptron there. So what is the Perceptron training rule? The learning problem is to determine a weight vector that causes the perceptron to produce the correct +1 output or -1 output for each of the given training example. So whatever the given training examples what we have, for each given training example, we need to produce an output of +1 or a -1 depending upon the weight vector. So here, to learn an acceptable weight vector, we have to start with the random weights. That is, begin with a random weight, then iteratively apply the perceptron to each training example and modify the perceptron weight whenever it misclassifies an example there. So whenever iterative process is carried out with the help of a perceptron on each training example, there is certain modification of the weight has to be done if it is a misclassification is been done for an example say. And this process is repeated until the correct result is obtained. That is iterating through the training example as many times as needed until the perceptron classifies all the training examples correctly. And this is how it does that. So weights are modified at each step according to the perceptron training rule, which revises the weight wi associated with the input xi according to the rule here. So whatever the incremental weight is there or the change in the weight is adding with the previous weight what we have, and the updated weight is given to the wi there, where you can observe the change in weight is given by neta into t minus o multiplied with xi, where t is the target output for the current training example and o is the output generated by the perceptron, and neta is the positive constant called as learning rate. So initially the learning rate will be of smaller value. So the role of the learning rate is to moderate the degree to which the weights are changed at each and every steps. As you can observe, the how the weights are changed with the help of the neta expression, that's the learning rate there. So it is usually set to a small value, that's of 0.1, and is sometimes made to decay as the number of weight tuning iteration increases. As the number of iteration increases, the weight tuning happens. So till we achieve the correct classification for each training example is continued there. So what's the drawback here? The drawback is that it performs the operation on the linearly separable data. But if it is non-linear at that time, it becomes difficult for the perceptron training to rule to classify the data there. In a simple way, if t minus 0 is 0, then we take a change in weight as 0. What happens at the time? There is no change in the weight, so no weight updation is required. Now suppose that the perceptron outputs a -1 when the target is +1, then what we need to do? So we need to alter the weight till we get the output as -1 there. Now let us see the simple example. Example here is, consider the following training set and identify the weight vector which classifies the example. Now let us see the input values are x1 given with the training set of values 1, -2, 0, -1. Whereas the desired target output is what? -1 there. So now we need to get a target output as -1. Till that we need to perform the perceptron training rule. So now initially let us assume the learning constant, that's the positive constant neta, is equal to learning rate as 0.1. And the weight vector is assumed initially as 1, -1, 0, 0.5. So now applying that to the network, we see the conditions of threshold, which states that it is linearly variable. And you can observe that if it is greater than 0, then its output is 1. If it is less than 0, the output of the perceptron is -1 there. So now the step what we are going to do here is wi multiplied with xi, where wi is given as 1 minus 1 0.5 and xi is given as 1 minus 2 0 1. When you multiply all these things, that's the matrix multiplication, we get the output as 2.5. So if you observe 2.5 is greater than the threshold voltage threshold 0, then the output is plus 1. But what was the target? What was required is minus 1 there. So we need to alter the weight. So how to alter the weight? We have the formula weight is equal to weight plus delta wi, where delta wi is given as neta into t minus o into xi, where we observed neta is given as 0.1, target output is minus 1, what we got the output was plus 1, so it is minus 2 multiplied with the xi, whatever the instant value of input is given there. Then when we multiply, this can observe the change in the weight, what we have got it now here. That is 0.1 into 2 is minus 0.2 multiplied with the respective matrix here. So we got minus 0.2, 0.40, minus 0.2 there. And this change in the weight is added with the previous value of the weight there. What was 1 minus 1, 0.5. So we get the new weight as 0.8 minus 0.6, 0.7. How? 1 minus 0.2, 0.8 minus 1.4 minus 0.60 is as it is, 0.5 plus 0.2 is 0.7. So now with this weight is multiplied with the input vector, which is constant there 1 minus 201. We have got the output as 1.3. As you can observe, the output has drastically changed from 2.5 to 1.3. So even, but now also the output is greater than 1, there is 0. Then the output here also we get as positive 1, but the target was minus 1. So we need to alter the weight again. And the process of altering the weight is repeated with the same method. As you can observe, weight is given by weight plus change in weight. And change in weight, we know the definition as neta into t minus o xi. And already we know neta is 0.1, target is minus 1, output we got was 1, so it is minus 0.2 is multiplied with the input value, so it is minus 0.2 minus 0.40 0.2. This is added with the previous value, so previous value was 0.8 minus 0.6 0.7 because of the previous modification. Now again with the same addition is carried out, so we got it as 0.6 minus 0.2 0.9. Now again multiplied with the input x, that is 1 minus 201, we got the weight as 0.1. Now observe again the output is greater than 1, so the output is still positive 1. It means that we need to again modify the weights and again the process has to be repeated. So if you see the repetition of process, we are doing the iterations till we reach the output target as minus 1 there. So now if you observe the change in weight is same and it is added with the previous weight, we have got it as 0.4, 0.20, 1.1. Now this new weight is multiplied with the x value and we see the output what we got was negative. So output is minus 1.1, which is less than the threshold, and the target output is minus 1. So we have achieved the target, then we have to stop processing the weight modification there. Okay, in this way, we have to apply the perceptron training rule to modify the weight till we achieve the target value there. And this is one of the example what we can easily consider to how the weights are modified. So same thing what we have explained, the algorithm is written in terms of an algorithm. They initialize the weight and repeat the weight for each training instance what we have there and compute the output for each every instance what we have there. So if the target output is not equal to the whatever the generated output, then we have to perform the weight modification and then add it to the previous weight till the target output is reached. And once it is done for all the training instance present in the X, then we can say it has been easily classified the perceptron training rule for the perfect output there. Okay, so we have to continue till and return the value of omega. So there are some problems occurring in the perceptron training rule, which is being solved with the help of gradient descent and delta rule there. So what is that? So perceptron rule finds a successful weight vector when examples are linearly separable. So as we can see, the perceptron rule is applicable for the linearly separable data. Whereas when it is non-linearly separable, then it converges towards a best fit approximation to the target concept. So what happens is that here we use the delta rule. which best fits the approximation till we achieve the target rule. The key idea behind the delta rule is to use the gradient descent, as we know the gradient in smaller wise decrement operation, to set the hypothesis space of possible weight vector to find the weights that best fit the training example. So we have to keep on decreasing or finding the hypothesis in the entire hypothesis what we have till we achieve the best possible result from the entire training example there. So to understand the training rule, that is the delta training rule, let us consider the training on unthresholded perceptron. That is a linear unit for which the output is given there. As you can see, the output is given with the help of OX is equal to W dot X, as we already seen the linearly varying parameter. So the above linear equations corresponds to the first stage of the perceptron, as we already seen that the single stage perceptron output without the threshold there. So what we have to do to derive the weight learning rule for linear unit, specify a measure for the training error. So whatever the training error if you are having in the design, we have to use that. That is to derive the weight learning rule for a linear unit. Specify the measure for training error of a hypothesis, that's weight vector, related to the training example. As you can see here, we are specifying the error, and we already done that with the help of a squared parameter. So when we do that and divide it, we can easily say that the error has been getting minimized, and we are till the target output is being achieved or classified. So where we can observe error is given with the help of vectors is 1 by 2 summation of the entire training example, that's for each and every training instance present in the entire trained data. So whatever the target output obtained for that particular trained example and the observed generated output is squared there. So that's the difference what we are having. And this is how we are performing the training error in order to use it in a gradient descent rule, where we can observe D is the set of training example, that's capital D. TD is the target output for a training example at point T there, D. And OD is the output of the linear unit for a training example of a D there, small d there. And DW is simply half the squared difference between the target output D and the linear output OD, summed over all the training example. So when you perform all these things, we can easily perform the gradient descent rule and identify the weights which are nearly possibly fitting to classify the data there. If you have any questions, go to the comment section, write down your questions, I'll reply to your question. Or subscribe to my channel, click on the bell icon for further notification, or share with your friends for the benefits. Thank you.